You ever watch sugar just vanish in your tea? Or wonder where all the salt goes in the ocean? I mean, it really does look like a magic trick, but it's actually a scientific process that's happening all around us all the time. In this explainer, we're going to pull back the curtain on the science of dissolving. All right, let's kick things off with a little puzzle. One that seems to, well, break the laws of physics. Take a look at this. We've got a huge polystyrene rod and this tiny little jar of liquid. Now, common sense is telling you there is no way that rod is going to fit inside that jar. But what if I told you it can?
Yeah, I know. It sounds totally impossible, so let's put it to the test. We're going to do a demonstration that honestly looks like a straight-up magic trick. But trust me, by the end of this, you'll see it's not magic at all. It's just some seriously cool chemistry.
Okay, watch closely. As soon as the rod touches the liquid, which is acetone, by the way, it just vanishes. It seems to melt away, shrinking so fast until the entire massive rod is completely consumed, disappearing into that tiny, tiny jar. How in the world is that possible? So what gives? What's the secret here? Did the rod actually just disappear into thin air? Nah, of course not. The answer isn't magic, it's pure science. And to really get it, we just need to learn 3 simple but really important terms.
Okay, let's get into the nitty-gritty. These 3 words, solute, solvent, and solution, are basically the building blocks for understanding how anything dissolves. First up, you've got the solute. That's just a fancy science name for the thing that's getting dissolved. So in our little trick, that big polystyrene rod, that was our solute. It was the star of the disappearing act.
Next up, the solvent. This is the liquid that's doing the dissolving. The acetone in the jar, that's our solvent. And, a little fun fact. It's pretty much the same stuff you find in most nail polish removers. And then, when you mix the two together, the solute and the solvent, what you get is called a solution. So that gooey stuff left in the jar, the mix of polystyrene and acetone, yep, that's our solution.
And hey, this whole thing isn't just for weird science experiments. You see it all the time. Think about seawater. The salt is the solute, the water is the solvent. Making tea? The sugar is the solute, the hot water is the solvent. See? It's the same exact solute-solvent-solution process every single time.
Okay, but just saying it dissolved doesn't really answer the big question, right? How did that huge rod fit into that tiny jar? To get that, we have to zoom in, like way, way in, down to the molecular level.
Okay, here's the big secret. The solute never really disappears. What's actually happening is the solvent's particles, think of them like a big crowd, they come in and they surround the solute's particles. They literally pull the solute apart, piece by piece, and just spread those tiny particles all throughout the liquid until they're so small and so spread out, you just can't see them anymore.
All right, so we get the what of dissolving. But what about the how fast or how much? What can change how things dissolve? Let's start with solids and look at a perfect example we all know. Making a cup of tea. Now this is where things get really cool. Check this out. An experiment was done with 2 cups of hot tea, both packed with as much sugar as they could hold. Then they took 1 cup and flash cooled it with dry ice. We're talking a crazy negative 78 degrees Celsius. So what do you think happened? Well, the result was crystal clear. No, literally. The cold tea just couldn't hold on to all that dissolved sugar anymore, so the sugar started forming crystals at the bottom. And this shows us a super important rule from most solids. The hotter the solvent, the more stuff you can dissolve in it. And that brings us to a new word, saturated. A solution is saturated when it's just full. It can't dissolve 1 more particle of solute at that temperature. That's exactly why if you try to add more sugar to that cold tea, it just sinks. There's just no more room at the end, so to speak. Okay, so for solids, heat is your friend. Got it? Simple enough. But what about gases? Well, this is where things get turned completely upside down. That's right, gases play by a totally different set of rules. For a gas, its ability to dissolve decreases as the temperature goes up. So, to put it simply, warm liquids are terrible at holding on to dissolved gas. A perfect way to see this in action is just by looking at ice cubes. That cloudy ice on the left, that's from regular tap water, which is full of dissolved air. When it freezes, that air gets squeezed out and trapped as all those little bubbles. But if you boil the water first, you're forcing most of that dissolved air to escape before you freeze it. And the result? That beautiful, crystal clear ice on the right. All right, we've talked solids, we've talked gases. Now let's bring it all home and apply these rules to a few more things you probably see every single day.
You ever leave a can of soda out in the sun, and when you come back, it's totally flat? That's our gas rule right there. The fizzy stuff in soda is carbon dioxide, a gas, and it's way less happy staying dissolved in warm liquid, so it escapes much, much faster, leaving you with sad, flat soda.
So let's wrap this part up. If you ever want to make a solid dissolve faster, you've got 3 main tricks up your sleeve. 1, heat it up. 2, stir it, which helps mix all those particles around. And 3, use a fine powder instead of a big chunk. That just gives the solvent way more surface area to work on. So, that disappearing polystyrene rod, it wasn't magic, was it? It was just a really, really dramatic example of the science that's happening all around us all the time. In your morning coffee, in a fizzy drink, even in the ocean itself. So now that you know the rules, you know about solutes, solvents, and how temperature changes everything, what other little everyday puzzles are you gonna solve? That hidden world of particles is out there, just waiting for you to take a closer look.